And what I wanted to do today is maybe a little bit of a divergence from a lot of the other talks. I'm going to talk about the squishy parts of open source software, communities, and precision medicine. And just to give a little bit of historical context, back in the 1990s, when I was in medical school, one of the first exposures to medical education was with probably a 60-year-old general surgeon. He was talking to a small group of us, and we were talking about things like electronic health records, for example. And he didn't really see the need for an electronic health record. He wrote things down. They were well kept, well understood. People knew what he was writing, and the terminology was clear. He also didn't see, for example, the role of healthcare or health insurance changing as much as it has. My point is that if we had looked at what precision medicine would become now, we wouldn't have necessarily predicted it. And I think if we look at 10 to 20 years from now, we're really shooting in the dark. We're shooting in the dark. We don't know where things are going to end up. But I will say that open source software and the communities that build and maintain them are going to be key in that. And there's no question in my mind. I don't think anybody on this call or on this in these talks would think that would be a statement that you can't argue with that. And again, 20 years ago, I'm not sure that we would have been able to say that. We wouldn't have thought that a lot of commercial companies would be involved and really driving the field. So the squishy parts. This is just one picture. I'll be honest, I grabbed this from Google. This is from the precision medicine group at UCSF. It's an overview of the way they're developing their program. But any precision medicine ecosystem is really a story about data, knowledge. You can see little people on here, so community and integration. And that integration is typically happening at the level of software. That software is often written in languages that are indeed themselves open source. And many of the tools that are incorporated in that integration process, that's storage of data, understanding and modeling our knowledge, a lot of those things, I'd say probably most of them, are at least based in open source software. So the precision medicine ecosystem, I suppose if we went through and tried to quantify it, in any given institution, has a very large component of open source software involved with it. And so again, the squishy stuff, this is very high level, but software is not just about accomplishing a task. Software encodes knowledge. And what do I mean by that? Well, if we think about some of the key capabilities that we have to have in order to be successful in knowledge and information integration for precision medicine, we have to be able to encode really complex ideas, really complex processes, and we have to do that in a way that is reproducible, shareable, auditable, and essentially that is software. And that software, if we write it well, encodes the knowledge that we needed to create it. Why is that important? Well, reproducible research is something that we've been talking about for a long time. But as soon as we switch over to talk about the patient context, that is precision medicine, we're talking about individual patients or populations and applying essentially rules to their care. And those rules are often complex, but they need to be highly reproducible, highly replicable in terms of their results. And ideally, we'd like to be able to share those those capabilities, those knowledge, those models across groups in order to implement not just a local precision medicine initiative, but a more global one. And Jeff Leake and Roger Peng wrote this article a few years ago, but next slide just kind of summarizes reproducibility, or the ability to recompute results, and replicability are two foundational characteristics of a successful scientific research, and I'm arguing that they're also going to be foundational characteristics of precision medicine. And there's been a crisis of confidence, certainly in basic research, but also there are some horror stories of applications in clinical research that can be traced back really to our inability to use computation reproducibly and replicability. So we have to really ensure this reproducibility and replicability. Sorry, not enough coffee. And the way that they propose to do this is to greatly expand data analysis education and routinely employ software tools. What does this translate into practice? Well, I'm sure you've heard a little bit from Wolfgang and maybe some others about some bioconductor approaches to this problem. But a core value in bioconductor, and I would say in all open source software at this point that's being developed for community use, is reproducibility. And biomedical research and precision medicine, even to a greater extent, has incredible complexity in the biological data that we're trying to interact with, model, and use. Because we're talking about precision medicine, we applications to patients or patient populations, we really need a very well understood approach to version control and to change management. So version control, yes, we use that every day, but we also need processes for integrating change into our precision medicine systems. And open source software, the ideal application of open source software includes all these kinds of ideas: continuous testing and integration, text-based workflow without a GUI. I'm working with a team now that's been used to working with GUIs, with graphical user interfaces, and in the research context. And as they've moved into the clinical context, they're recognizing that graphical user interface-based workflows are not necessarily the best approach for the kind of auditability and reproducibility that you need in a clinical context. Literate programming approaches and documentation are really critical. Our care teams, those who interact with precision medicine applications, are large and diverse. So anything that we can do that can tie our teams together, our application teams, our software development teams, our clinical teams, and all the way down to the patients themselves, anything that it improves our ability to document and communicate what we're doing is a good thing. Open source software packages that have been successful have quite a bit of education built into them. And that education we can pass along, the approach to education as well, we can pass along to precision medicine applications. And finally, the open source software ecosystem, and particularly the social coding ecosystem, offer lots of mechanisms for fair, findable, accessible, interoperable, usable data sharing. And Bioconductor, Galaxy, MBOSS, all of those packages have capabilities for accessing and reusing data that have been shared that way as well. Again, in thinking about the applications that we have in precision medicine, we couldn't list them, right, if we wanted to. So what we really want and need is a core value of reuse and interoperability. And what do I mean by that? Well, lots of closed source softwares are really good, sometimes best of breed, in doing the tasks that they were designed to do. But in precision medicine, because the applications are so diverse, really a much more modular approach that allows not just reuse of modules, but rejiggering of modules to make them fit for purpose is really important. And I caught the tail end of the discussion about GPL licensing. There is an advantage to a viral license if folks can work in that kind of ecosystem, because those changes then feed back to the knowledge that's encapsulated in that software, at least ideally. I'm not arguing that GPL is the right license, but that ideal of reuse, interoperability, and then feedback of new fit-for-purpose software is something that really open source software and social coding, I'm mixing the two terms now, is really good at. Software adds value, and there's been lots of examples throughout the day that you've heard where software really takes resources that exist and have been maintained by, for example, NIH, the NCBI Gene Expression Omnibus database, which has 450 or 4.5 million samples as of 2 weeks ago. To take software and to use it as a bridge between the data resource and a community, and we'll come back to communities in a bit, to take what's in the database. This is what a GeoAccession looks like if you try to extract it from Geo directly, to this with a simple tool, GeoQuery, for example. With one line of code, we can take something like GeoQuery, encode all the knowledge that I use to create GeoQuery to access this database, convert these data into a form that makes this kind of understanding of data. This is a PCA plot of 4 different kinds of breast cancer, or 4 different kinds of cancer, and their normal counterparts. I think it's 300 or some samples. And we can do this in about 10 lines of code. So we've taken something that people can search, find, a postdoc can search and find information that might be relevant to a precision medicine application in a geo database. And we can now using software, train them to make those data, apply those data in their workflows. And this is actually a passion of mine right now. Open source and social coding enables communities. And we're struggling with this in our own precision medicine initiatives at the University of Colorado, and I imagine there are a lot of other places that are as well. If we expand a little bit beyond the open source software community, precision medicine itself is the applications of precision medicine themselves really are built around, or they can benefit from communities. And so this is just a quote, I should have sourced it, but there's no power for change greater than a community discovering what it cares about. And really what this comes down to is communities are really important and powerful engines for change. And the bioconductor data storage the objects that enable interoperability are a great example of how we've been able to use community approaches to develop software, and also really just thinking around reproducibility in biomedical research. But communities in precision medicine require something more than just a community of software developers and users. It also requires domain knowledge. So areas that are shared interests and have key issues that you can identify in a group that can act on. The community itself, which is the relationships that are built through discussion, activities, and learning. And then the practice, and that's the body of knowledge, the methods, the stories, the tools developed. These communities of practice can be really powerful. And software development, open source software communities have sort of epitomized how we can do some of this, build communities of practice, large ones that have real impact. Communities really, I know this is probably preaching to the choir, but these are things that sometimes need to be said to institutional leaders. Communities provide really a space and a structure for people to align around shared interests and goals. And by communities here, I mean named communities. I don't mean loose ones. If you can give a name to a community, you can recruit new people. You can recruit new people, and you can build based on that community. Effective communities are aspirational and practical. You need both. You need something to shoot for that you may never attain, but you also need to get stuff done. Communities connect people, organizations, and systems that are eager to learn and work across boundaries. And precision medicine is sort of the definition of working across boundaries. We'll come to that in a bit. Effective communities build a common agenda, metrics, outcomes, and means to achieve them. So that's a governance kind of process. What do we want to do? How do we want to do it? What defines our success? And communities enable participants to share results and learn from each other, thereby improving their ability to achieve rapid yet significant progress. And again, showing how a couple of these communities, and again, looking at the list of speakers, I'm sorry that I haven't included everyone here, because everyone who's speaking has a very significant a very significant community built around their software. But I wanted to include this slide because I told Adam I'd talk a little bit about my background. Bioconductor, the top slide there, has a support site. And when I joined back in 2002, joined my postdoc program, there actually wasn't really bioinformatics at the time, or there was very little. People didn't practice it, and there was certainly no training. So how do you get training? Well, what I started to do was to read. So I learned about the Bioconductor project. How did I learn about it? Well, my group, the group that I joined, was using MATLAB at the time. And I don't mean to poo-poo MATLAB, but it was going to be $40,000 for me to get a license to use MATLAB. There's got to be a better way. So sure enough, Bioconductor was just getting started, and they had an email list. I joined the email list. Essentially, I had joined a named community, Bioconductor, and I joined it by joining an email list. Started reading those emails, and people were asking questions, some simple, some more complicated, and many of them had no answer. Those no answer questions led to software development efforts. And in the process, I was learning about what the community needs were, and I was also learning the software. I started to answer questions a little bit. And one of the needs that came up was this NCBI Geo database was growing. It was like a real thing back in around 2006. So Robert Gentleman reached out to me. He was the head of Bioconductor at the time, and phone call out of the blue. Hey, Sean, you're at NCI, or you're at NIH, right? There's a group at NIH who's interested in working with Bioconductor. Can you talk to them? Because it seems like you're spending a lot of time thinking about Bioconductor. I said, sure. So that led in about 2.5, 3 weeks to GeoQuery. And it actually hasn't changed much since 2007. But that entree into the biomedical research that I do today was through a community that was based in open source software. And I think that that's a really powerful paradigm that's repeating over and over again. Transitioning a little bit, in our world of big data, businesses are relying on data scientists to glean insight from their large, ever-expanding, diverse set of data. And while many people think of data science as a profession, it's better to think of data science as a way of thinking, a way to extract insight using the scientific method. And why is this important? Well, adult learners, I'm not going to go through all of these, but adult learners are a little different than the folks who are in school. And I'm assuming that a large number of folks on this call are actually adult learners. You've done school, you're through school, and you're working, and you're surrounded by people who you either need to train or work with, who don't necessarily have the skills that you think that they might want or need, and vice versa. Yourself, you may want to learn new things. And adult learners have lots of challenges, but the community-based the community approach to thinking about problems is really quite powerful for adult learners. If you can find the right community or communities to plug into, you can learn quickly. You can be encouraged to do so. You can be self-directed and motivated, and you can choose really how you want to learn within the community context. Why am I harping about this? Well, if we want to be successful in our precision medicine efforts, we're going to have to draw from non-traditional places, and we're going to have to start working with folks early on in their careers. So I have highlighted here some K through 12 student training opportunities. So we don't traditionally think of starting to build a precision medicine, a data-focused precision medicine workforce based on K through 12 training opportunities. But particularly if we want to build a diverse, equitable, inclusive precision medicine initiative, then we really do need to reach back further than what we traditionally do when we're thinking about training. And that's assuming that this is a linear pipe. This is going to travel a long distance, but it's going to go in one direction. We also need to think about recognizing that the data science workforce is very nonlinear. That building a data science workforce is very nonlinear. It's multifaceted. There's a large diversity of people who call themselves or work in data science. And one project that I was involved with was to design a course that was not to teach necessarily computer science, but to take computer scientists and expose them to projects that were, it was a project-based course that were maybe a little off the beaten path and maybe a little less lucrative in a sense. So the three were social network analysis, thinking about how we want to impact people's behavior, cancer research and applications in precision medicine in cancer. And then the last was actually battery design. As we move to a green economy, we need to be able to store power. The idea there was to try to take people who are already trained in data science and pull them into these fields that they wouldn't otherwise be exposed to. So again, building a data science workforce that will be important in precision medicine. So precision medicine ecosystem in 2030, this is from a paper from Francis Collins, I think back in 2019, includes mostly people, right? There is some science here, but a lot of this is about how we build a workforce and build communities around improving health, and how we can do that in the setting of precision medicine. So precision medicine ecosystem, maybe a different way of thinking about it is, yes, there's software involved. Communities build that software, but it's built by people for people, and that's a community-based effort. We can use software to break down traditional silos of domain expertise, and that's going to be really important as we move forward with precision medicine, thinking about how we move away from these different teams that have specific areas of expertise with walls between them to a much more incorporated, federated model where people own the pieces of the precision medicine ecosystem that they need to own, but that there's a lot of interoperability and built-in pipes between those pieces. I'm going to skip over this for time, but this is a really interesting paper, Ground, a data context service. I'm going to stop there for any questions. And apologies for the soft, squishy parts, but I think they're really important.
Soft, squishy parts are our favorite. Sean, I suppose my first question really is going to be about community building, because the communities are the momentum that drives open source projects forward, and that drives sort of like really any scientific or otherwise initiative. You seem to have a real talent for building those. So could you just say a few words about how do you manage? How do you manage to to have built several successful communities in the bioinformatics space and outside? What's the secret sauce?
Well, first, I think I will say that I recognize that I didn't build those communities. Maybe I had a part in them, but communities build themselves. That's key to understand. You can't sort of put someone in charge and magically create a community. But there are some things that I think are sort of reusable pieces, generalizable thoughts. One is if you're in an environment where you don't recognize how to build a community, recognize that fact. So when I arrived at the University of Colorado, for example, communities here are built by leaders saying, I'm going to invite 10 people to a meeting, and we're going to establish a working group, and we're going to email each other. And sometimes those communities can grow, but often they don't. They remain closed. So something that we're trying to work toward is allowing anyone to create a community. And by create a community, I mean give it a name, put it on a website, establish a communication plan. So I talked about the Bioconductor email list, right? Imagine that all it took was an email list, well, and good software, but an email list to build a community. Sometimes that's all it takes, but a recognition that a community can be built, that I can raise my hand and say, I want to build it, help me, and then a communication strategy. As communities grow, it's really important to think about how the community is growing and why it's growing and how you want it to grow in the future. So with Bioconductor, for example, it took many years, 15, 18 years, for us to realize that in order to grow the community more effectively, we had to be more inclusive in driving that community growth. So we built a community advisory board, and that community advisory board was entirely based on nominations, self-nomination, literally self-nomination. And just by introducing that new community action group, we've now taken all the ideas that are pouring in there from outside that community advisory board, inside the community advisory board, and spun off lots of new things that we hadn't done before. For example, we have sponsorship opportunities for healthcare, for childcare at our conferences. Came out of the community advisory board.
Wow.
Empowering people is I guess and the next phase, and community advisory board was one way of doing that. But as communities grow, empowering them is important. So.
Yeah, let me know where your next conference is, and I'm going to bring my 2.5-year-old. Yeah, wonderful. Yes, that's great. Could we spend a little bit more time also talking about your background? Because as I kind of jokingly referred to in my introduction, it is a little bit all over the place. How did you go from airplanes through genetics to medicine? How did that happen?
That's a great question. I wish I could tell you what my thoughts were at the time, but the commit message doesn't exist. But at least if I reverse engineer, it was probably around junior year of college. I was realizing that there's an aspect of engineering. I love engineering. I still think of myself as an engineer first, but working with people, interacting with people, having impact with individual people is something that I think a lot of us find really rewarding. It's maybe not necessarily a primary role for everyone. For me, it was. I wanted to be a doctor. Decided that I would be a doctor, but it was that switch from I think I want to build things to I want to build things, but I want to build relationships with people. And that was a really cool switch for me. It was not. I did not want to be a doctor when I was growing up. In fact, I didn't think that was in the cards at all. It was too squishy. Engineering was not. But then throughout the rest of my career, there's a lot of need out there. And Adam, you and Biomage are addressing one of those needs, one of those critical needs, which is building community around open source software and precision medicine. We should all take the opportunity to identify a few of those things and follow them, because that's where we find passion. If we could line those with our jobs, great. Sometimes we can't, but it's still fun.
Absolutely. So the advice seems to be follow your dreams, and one day you'll end up in a leadership role in Colorado at a large cancer center.
It takes a little bit more care than follow your dreams, but I would say don't ignore your dreams. Let's put it that way.
Wonderful, Sean. Thank you so much for being here.
It's been a real pleasure.
Really appreciate your time. I know it wasn't easy to schedule, but it's great that you were able to join. And thank you so much. I'm looking forward to interacting with you in the future.
Take care. Thanks again.